a taste. All the highs and the lows, no, you'll never be the same. I don't really wanna hurt you, but I can't control the pain. If you're sticking by my side, maybe we could be okay. Okay, maybe you could be the change I need today. I promise that I've never felt this way. I really hope that you will choose to stay through all the pain.
I know you told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. And guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away. As you fade away. As you fade away. As you fade away.
Already mic testing, mic testing. Okay, perfect. Let me go to my main camera. There we go. Already we're live, and as you guys can tell by title and thumbnail, today I'm going to be working with machine learning or math and machine learning. Finally, after let's say 70, I think today is day 75. That said, after 75 days, finally I'm going to be working with machine learning. That said, I'm going to go to my gameplay screen, but before that, I just realized something. I'm gonna get my webcam a bit lower. There we go. Yeah, because I did sort of change my webcam here. Not like webcam the way I really portray my webcam. Also, what in the... Hold on, let me go to my gameplay screen. What? Okay, I just opened Wuthering Waves, but I did not really play anything on it or so I don't know why did that stuff open there. That's it, machine learning, let's go. And today I am just streaming horizontally because I want to see if that makes my stream quality better. Hey, hold on. I'm gonna open my timer as well because I will be going in increments of 25 minutes to 5 minutes break. Every 25 minutes, I'm gonna be getting a 15 minutes break. That said, let's see. I want to see real quick if that helped with my stream quality at all. Just streaming in one stream. Hold on. No, why is the stream still not at its should I say max clarity? Even though I'm just streaming once. Should I increase my bitrate? Hold on, let me try to increase my bitrate. Okay, I'm gonna close the stream just for a tad bit and then I'm gonna get back here. Hold on. Alright, mic testing. There we go. Did that like help with the stream? Hey, that should help with the stream quality, right? That said, what are you learning today exactly? Actually, I have not gone over that yet because I am still working. I mean, I did not really work on this at all off stream. Although, hold on. I just wanted to make this stream clearer. Okay, I'm just streaming horizontally today, but then it still shows that the stream still is not nearly as clear as I would want it to be. I wonder why, because everything else does look pretty clear. Hold on. Okay, I think the first 10 minutes of the stream, I'm just going to be wasting it up. Okay, because I want this stream to be clear, because it makes sense that I'm multi-streaming and it's not clear, but if I'm just streaming on one platform and coding my stream once, it should be clear, to be honest. If it's not clear, that wouldn't make any sense, right? Bitrate and then multipass. Okay, full resolution. Quarter resolution. There we go. Profile high is good. Bitrate 2. Tuning high quality. Okay, and then... Okay, presets lower but better quality. And then that's going to be constant bitrate. I'm going to change it to like 20,000. Just because I want to see what it does. Besides cooking my GPU up. I'm gonna check if that made a difference. Hold on. Give me a quick little second. Let me go there. Did it somehow make the stream a bit more glitchier, laggier? No, it looks pretty clear. Hold on. Yeah, I know. I was doing this off stream, but then I thought that I'm getting a bit late, so I did actually start the stream up. Because let's be honest, if I want to convert these to YouTube videos or anything of the sort, I need it to be clear. I cannot have it be crappy. Hold on. So 20,000 kbps. That's what I'm getting with 30 frames per second. And then my output is going to be alright. So I'm using NVIDIA's H.264 encoder. Is that correct? Alright, hold on. Give me a sec. I'm going to close the stream and on it back again real quick. Hold on. Already mic testing. Okay, I went with this time the third setting, which said that this is going to be the slowest but with best quality. Hold on. I want to see if that helped whatsoever. Did it though? Wait, is it? Interesting. You know what? Yeah, screw it. I'm wasting a whole bunch of time, so I'm gonna figure this stuff out off stream. I'm just gonna close my stream one more time and then because my stream looks so clear here, but when I'm on YouTube, it does not look nearly as clear. Thing is, it's yeah, it's not clear. All right, that's pretty much good. Let me just check if I'm streaming right now. There we go. Okay, I said I just used 10 minutes, so and that was pretty much it. Yo, Hiding Pixel, appreciate you joining the stream. Alright, so today I will be working with math and machine learning, and this is Claude's brand new chat, so let me go with something like, let's say, a live exclamation. And yeah, I will be touch typing and following a Pomodoro timer which starts now. Alright, let's get to work, I guess. Okay, there he is, back to archives, roadmap in hand, phase 1 in the rare view. You built a real scraper, you solved a real data into real database, and you verified it yourself instead of trusting a green checkmark. That's not beginner behavior, that's the instinct that separates people who finish this 365 days from people who quit at 840. That's it, but I'm gonna let you coast on that win. Phase 1 was the bedrock phase. Phase 2 is where you stop being a script kiddo who calls a dot fit. I never knew there was a dot fit method on a model and actually understand why the math makes the model work. Anybody can import skit-learn and get number out. That's not engineering. That's magic-button-pressing. You're not here for magic buttons. One correction before we start. You type Sensei I'm live, but the deal was Sensei. Alright, who cares? Okay, exact phase, both exclamation points. I'm flagging it, not blocking it since your intent is crystal clear and you're clearly here to work. Say it right next time, okay? Phase 2 opens with applied math, linear algebra, calculus, probability/statistics. Before I pick a starting point and start throwing terminology at you, I need to know what's already in your head. Okay, where's your math background actually right now? Oh god. Why the frick are you so smart? Guys, I'm the dumbest person if you guys think I'm smart. Maybe sort of, I'm getting there. I'm not at the pinnacle of the smartness yet, but I'm getting there. Last time you did web scraper and now you're already onto machine learning? Actually, yeah, because my, whatchamacallit, that was basically a mini project for my roadmap. Hold on, let me pull it up real quick. And that was the mini project for phase 1, so building the project did not really take as long because I spent 74 whole days learning the prerequisites that I would need in order to actually build my project 1. Now I'm starting with phase 2 and today I think it's day 75. If anything, I feel like I'm kind of slow out here. Okay, barely remember high school algebra. Comfortable with algebra, shaky on anything past that. Took calculus/linear algebra in college, but it's rusty, so all that I use. I barely remember high school algebra. Should I go with that? Nah, I'll go with option 2. Okay, good, that's honest, and it's exactly what I needed to hear. That tells me exactly where the floor is. Comfortable with algebra means you're not starting from Are we gonna be learning math on stream? What the hell? Okay, you understand variables, equations, functions. Shaky past that means calculus and linear algebra are going to feel new even if you've technically seen those words before. Here's the plan, and I want you to understand why I'm sequencing it this way, not just accept it blindly. We started with algebra, not calculus. We start with linear algebra, not calculus. Reason: almost everything in machine learning, your data, your model weights, a whole batch of training examples get represented as vectors and matrices. Calculus tells you how to adjust those numbers, but linear algebra is the language the numbers are written in. You can't learn to edit a sentence in a language you can't read yet. That does make sense. You've done ALG, algorithms? Actually, I did work with data structures and algorithms, DSA. That said, we're not doing a math class here. Oh, thank God. I mean, it's not like I hate math. I just don't like it. Okay, we're not proving theorems. You get exposed and intuition on every concept. Real code showing in action, and enough to recognize it when you see it in a model later. That's the deal for the pacing philosophy. Full coverage, no death by drilling. First concept, the vector. Not the arrow in physics class version, the machine learning version. Quick check before I go further because I'm not assuming anything today. Have you used NumPy before at all, even briefly? I have never used NumPy. Oh, NumPy, there we go. However, when it comes to math, do you think that I need a lot of practice as opposed to, let's go with something like as opposed to just getting exposure? Because math, unlike anything else, is something that I really need to be exposed to. I mean, that I don't really need to be exposed to. Lectures, eh? Huh. Okay, let me check if my audio is going good. Or mic testing? What if I get closer? The closer audio sounds so good. I mean, I guess I'm just going to be staying closer. Thing is, I wish I could get my mic stand a bit more towards me, which I could totally do. Okay, a real question deserves a real answer, not a dodge. No, you don't need a heavy practice on math itself. Here's why. And I want you to actually sit with this. Let me go a bit lower. So we're getting into the nitty-gritty of how AI works. I think that's the gist of it. Here's why, and I want you to actually sit with this reasoning instead of just taking my word for it. You're not going to be doing linear algebra by hand in your career. Wait, I'm not? I thought that's what people do. Nah, they probably use AI to do that now. Nobody hand computes eigenvectors? Eigenvectors? I don't know how to pronounce that. On the job, when you're building an agentic AI system, the math is happening inside libraries like NumPy, PyTorch, and scikit-learn. Your job is to understand what those operations mean and why they're being used. Not to be able to grind through a 4x4 matrix multiplication on paper under exam pressure. That's a fundamentally different skill than a past linear algebra final. You already flagged this yourself as the basic philosophy, full exposure, not deep mastery. And math is actually the phase where that matters most. Because math is where beginners get seduced into over-drilling on paper mechanics that a computer will do for them anyway. where you do really need real reps, not the arithmetic, but the intuition. What a vector represents in a machine learning context: a row of data, a set of weights. Words and stuff are split into tokens. Oh, I see. And then they're represented through vectors that tell the system what word is most likely to appear. Oh, I see. Okay, and also, I wanna... never mind. I was gonna say something about my camera, but I guess I'm just gonna hydrate my lips. I wanna later on in my break test my camera's zoom, because unlike before, now I'm not sharing my webcam or a video capture device. I'm sharing a window capture device. My third screen, or my third monitor actually now, it's only in charge for my webcams. Because apparently I realized my webcam was not nearly as clear, which I don't think it still is. I still gotta like work a bit more on it. Hey, that's the basics I know. Oh, I see. Okay, what matrix multiplication does conceptually? Combining / transforming data. What a gradient means: the direction that makes your model's error go down. I remember why I turned around. I wanted to wear my glasses on. I look with my glasses. But don't quote me on that. I guess we're gonna go over all those topics. Okay, why probability shows up everywhere? Models don't output certainty, they output confidence. Models don't output certainty. Oh, I see. That intuition you build through seeing it in code and re-encountering it across phase 2 and phase 3, and not through isolated math drilling. You'll meet the same ideas again when you're building neural nets in phase 3, and that repetition is what cements it, not flashcards now. So, zero NumPy experience, that's fine, that's exactly what I expected, and it means we start from zero, no assumptions. A clean slate. Vectors, machine learning style. A vector is just an ordered list of numbers. Wow, that is something important. That's it. A vector is just an ordered list of numbers. No arrows, no physics. If you had a house with 3 bedrooms, 2 bathrooms, and 1,500 square feet, that house as a vector is 3 to 15. Okay, it's just an ordered list of numbers. Each number is a feature. A whole data set of house is just a stack of these vectors, which is what we call a matrix. Wow, that one sentence. No, that one paragraph. It had so much information in it. Hold on. A vector is just an ordered list of numbers, got that. Each number is a feature. A whole data set of houses is just stack of these vectors. A whole data set of houses is just stack of these vectors, which is called a matrix. Before I show you NumPy code, does that framing of a vector as just a row of features describing one thing make sense, or do you want to hit it from a different angle first? I understood it. Of course, just for now, because I just read it. I will need more practice, but I feel like I understand it for now. There we go, let's end it. Okay, good. That's the right level of self-awareness. You're not claiming mastery you don't have. Where's my GPU temperature? Interesting. Probably fix that later. Okay, good. That's the right level of self-awareness. You're not claiming mastery you don't have. You're not panicking that one read-through isn't enough. That's exactly the composure I've seen from you. Catching your own bugs in Project 1. You trust your gut, but you verify before you fully commit to believing it. Okay? And you're right that it'll take more than one read. That's not a flaw in you. That's just how this concept sticks. You'll see vector equals to row of features. Again, when we load real data into NumPy in a second. Again in phase 2 when we do regressions. Again in phase 3 when it's literally the input to a neural network. Repetition across contexts, not just grinding the same definition 20 times today. I see. I'm gonna try coming in front. Yeah, my PC is removing the hottest exhaust the exhaust fan, the wind that it actually removes outward is so hot. I don't know what's that wind called. Okay, let's make it concrete right now. Here's a vector representing one house in actual code. House equals to 3 to 1500. That's a plain Python list. But NumPy gives you something built specifically for this, an array, because plain Python lists are slow and cannot do math the same way we need. What's the difference? House underscore list equals to 3 to 1500. House underscore list multiplied by 2 duplicates the list, doesn't math it. That's almost certainly not what you want if you're thinking mathematically. You want every number doubled, not the list repeated. Now with NumPy, import NumPy as NP. House equals to np.array, where I have a list of numbers, which is also called a matrix. I remember that. Hold on, let me drink some water. Did you guys hear me when I said that? Or do I need to come really close for you guys to hear me? I need to be really, really careful when drinking because I don't want to spill. Okay, so np.array 3 to 1500. And then house multiplied by 2, output 6 for 3000. Oh, okay. Actual multiplies. There, I'm gonna stop hearing myself twice now. Okay, actually multiplies each number by 2. That's right. That right there is the whole reason NumPy exists. Regular Python lists don't know how to do math on themselves as a unit. NumPy array. There we go. The guys, under my legs is a wired mess because of all these freaking wires attached to these things. Okay, regular Python lists don't know how to do math on themselves as a unit. NumPy arrays do. That behavior is called vectorization. And it's the foundation of basically every machine learning library you'll ever touch. So Python cannot do math on themselves. Regular Python lists don't know how to do math on themselves, but NumPy does. Array is basically like a list. And that process is called of doing math on ourselves is called vectorization. There we go. Before I go any further, I want you to actually run this yourself, not just read it. Your task, open Visual Studio Code, create a file in your Python underscore folders, install NumPy if you don't have it, and run both of those blocks. The plain list multiplied by 2 and the NumPy array multiplied by 2. Send me back your actual code and your real output. Okay, so I'm gonna go ahead and grab my Visual Studio Code out here, and then I'm just gonna... I wanna commit everything. Okay, I'm gonna commit all these things into my freaking GitHub real quick. Not right now though, but later. I'm gonna create a folder called phase 1. There we go. No. I created phase 1 in the wrong place. I'm gonna delete this. I'm gonna go there and I'm gonna create one called phase 1. phase underscore 1. All right, and then everything goes inside of my phase 1. For example, my Alembic goes inside my phase 1. My markdown notes goes inside my phase 1. I think actually, yeah, screw it. I'm just gonna have my markdown notes inside of my phase 1. My Python files inside of my phase 1. My pandas inside of my phase 1. And my polars inside of my phase 1. Yeah, alongside screw it, my database also goes inside of my phase 1. Let's... Fine, I'll get my CSV files in my phase 1 too. Who the frick cares? Not ask me again. Alright, and then I'm going to go with students.csv and then alembic.ini, alembic. There we go. And then we're going to go ahead and create a phase 2. Alright, now for my phase 2, or inside of my phase 2, I'm going to go ahead and create another folder called Python. Underscore files. Okay, well, I'm going with NumPy, right? Nah. That's not good. That's good. No? Okay, this is getting confusing as hell. Oh, wait, now my bad. There we go. Python underscore files. Okay, and then I'm just gonna go here and I'm gonna create a Python file called numpy.py. Oh, okay, that was a lot. Okay, before anything, I'm gonna say, Sensei, before I do that, can you tell me the command that I will be needing in order to install? Let's go with something like in order to install NumPy. Okay, and then let's just go ahead and send it. Good instinct asking before you blindly try something. Okay, look, I knew it's gonna be something like this. I just wanted to confirm, okay? I don't want to install the wrong thing. Okay, there we go. Then later I'm gonna find a way to like commit that stuff. And then I'm gonna say something like done. Already satisfied in NumPy 2.5.0, that's not a fluke. Now go do the real task. Write both blocks in your file, okay. I'm actually gonna go ahead and let's say grabs Claude's chat in my other window as well, just so I can use it as a reference. Alright, so now I'm gonna open Visual Studio Code. In my Visual Studio Code, I'm gonna zoom in, I'm gonna close that stuff, I'm gonna exit my terminal, and we're gonna go ahead and exit webscraper.py and whatever the other thing was. And I'm gonna go ahead and let's say firstly import NumPy as NP, which I'm assuming is going to be a universal format. And then we're gonna go ahead and create a variable called house_list that is going to be equal to, let's say 3, 2, and 1500. Yeah, this is a list. It's not a matrix. Yes, it's not a matrix yet because I'm just creating this as a Python variable. And then I'm going to go ahead and print something like house_list multiplied by 2. Yeah, I know exactly what this is gonna give me. It's gonna give me 2 of these lists. And then next up, I'm gonna go with another variable called house, because I can't really keep it as house underscore list again. House is gonna be equal to my numpy dot the array method. Was it the array method? It was the array method, which is going to be consisting of a matrix of 3, 2, and 1500. The entire thing is called a matrix. A singular stuff in the matrix is called, I forgot what. Okay, and then we're just going to go ahead and let's say print. I'm going to print my house multiplied by 2. And then we're going to hit Control S to save the code. I'm going to hit Control / to get my terminal out here to run the program. Now, I'm currently going to change my directory to, let's say, something like, change directory to Python. Oh god. Underscore files. Okay, and then once I'm done changing my directory, I'm going to go with py numpy .py. There we go. Okay, so one of them just duplicated my list and the other multiplied my list by 2, or my matrix by 2. And say it worked exclamation. However, I had a quick question. Let's go with something like quick question. Okay, the entire list in NumPy is called a matrix. And the process of doing a math on itself is called vectorization. Okay, let's go with vectorization. Okay, what is a single what is a single oh wait, all right guys, time's up. Hands off anything that's not distracting. Hands off anything that's not distracting. We're on our break. Who's there? I don't even know how to do this stuff open.
Easy. I don't mean you any harm.
I don't mean you any harm. Oh wait, I sort of remember. Oh wait, is this the same exact story from yesterday? I think it is.
You don't look like you're from Xuanfang. Who are you? Why?
Is this...
I came to find someone from Jinzhou.
Jinzhou. So you came through the South Mountain Gate. Does this mean Jinzhou knows what's happening here? Are you the reinforcements they sent?
I lost my progress. I can skip this, but then I'll just watch it through it. No way I lost my progress. What the hell? My name is Rower. You can think of me as the reinforcement.
That name. I've heard it somewhere. Golden eyes, black hair, and a tacit mark on the back of your hand.
Golden eyes.
Could it be? You're the one from the Battle of Norfolk Barrens. The one who fought alongside General Jian and drove back the Threnodian Overthrax. Rover?
I'm here on behalf of Jinzhou's magistrate. Can you tell me what's happening in Xuanfeng?
Yes. My name is Liang Yu, and I serve under Meng Zhou's Ministry of War as part of the Xuan Triad. But now, I'm the only one left.
Okay, I watched this yesterday. That's the reason I may skip this, because I don't want to waste time. I've already got a video on this part. That is the one thing that I'm going to skip because I watched that whole stuff yesterday.
I'm sure you have a terminal on you. One moment, I'll share the access.
I've watched this as
Xuanfang
well.
Hold has deployed Skywatch rings everywhere to monitor tacit Discord activity. They can track this letter carries her frequency. With that, we should be able to track some of her previous movements.
Yeah, I'll have to find her. I mean, I'll have to follow her.
Locator readings are normal. So
There we
we're
go.
safe for now.
This is where I stopped
Like she
yesterday.
said, the priority right now is finding Yang Yang.
Oh wait, I don't need to follow her?
You said you traveled with Yang Yang.
That's right. I hope she's safe. Oh, while I'm at it, I'll unlock access to a cloud ride for you as well.
Cloud Ride? Is it similar to Leroy's expedition motorbike?
It's a type
don't-
of transport vehicle developed by Mengzhou's Huashu Academy. Very useful for quickly navigating rough terrain.
Oh, am I gonna get like a scooter or something? A vehicle to like drive on?
Since you already have a means of transportation, I'll just share the functions with you.
No, I needed it. I wanted something cool. Expedition motorbike, let's go! The Expedition motorbike helps you move faster. Its functionality is improved through upgrades, okay? Motorbike features. When riding the Expedition motorbike, you have access to features such as acceleration, boost, drift, and bounce jump. While moving, a force field is deployed around the Expedition motorbike, and the resonator will be forced to dismount upon taking damage or being controlled after the force field is down. I see. You can summon the Expedition motorbike or adjust the relevant settings via the utility wheel. The motorbike cannot be summoned while in combat or when there is insufficient space. Okay. You can drive this Expedition motorbike in both first-person and third-person views. Let's go! Click POV to switch between different views. That's so cool. Hey, there is a speed limit when riding the motorbike on Star Torch Academy campus grounds, and boosting will be restricted. There are certain areas with restricted access for motorbikes. Riding the motorbikes and using boost on decorated roads does not consume energy. Alright guys, that's it. Time's up. Hands off anything that's distracting. Move on to... get back to work. I'm gonna get my timer up there. There you go. Kind of tiny, but it's visually visible. Where was I? What is a single character in a matrix called? What is a single character in a matrix called? That output is exactly right. Okay. From the array, you can literally see vectorization happening in front of you. That's not a theory anymore. That's proof on your own screen. Now, before I answer your question, I have to stop you on something because letting this slide would set up you to be wrong later, and that's worse than 2 minutes correction now. What you just ran is not a matrix, it's a vector. Here's the distinction, and it's important. A vector is a one-dimensional list of numbers, one row, one column. Just a straight line of values. NP.array 3 to 1500 is a vector. One house, three features. A matrix is a two-dimensional row and columns. It's what you get when you stack multiple vectors together, like if you had three houses, not one house. Houses equals to NP.array. Okay, so we got 3 to 1500, 4 3 2200, 2 1 900. That's a matrix. Okay, a matrix basically means multiple vectors in one list. 3 rows, 3 houses, 3 columns, 3 features each. So, single house equals to vector. Multiple houses stacked equals to matrix. Same underlining object type in NumPy. They're both called arrays, but mathematically they're different things. Dimension count is what separates them. Now your actual question. What is a single value inside a matrix called? Good question, and here's the real terminology. A single number inside a vector is called a matrix. inside a vector matrix is called a scalar. Well, technically, scalar refers to a standalone single number in general, like 5 by itself, no brackets. When you're talking about one specific entry sitting inside a matrix at a particular row slash column position, you call it an element or an array. Oh, element was the word. Element or an entry. So you'd say the element at row 1, column 2, and that individual value once pulled out is a scalar. Quick check, does that vector versus matrix distinction click, or do you want me to show it with more houses added to the matrix stacking idea? I think, I understood. However, before we move on our work with anything, I was just curious as to knowing what are all the topics that we will be covering in phase 2, and how, okay, in phase 2, and what topic are we currently on, and how many categories does it consist of, before we move on to the next topic. Also, if it does consist of a category, does that category have subcategories? There we go, and then let's go ahead and send it. It's better to know what all you're going to be working on rather than just blindly diving in. Good question to ask before diving deeper. Not after you're 3 topics in and lost on where you are. That's a map reading instinct, not stalling. I'll give you the real structure, not a vague gesture at it. Phase 2 has 3 main categories. The Project 2 caps it off. Here's the full breakdown straight from the roadmap. Category 1, Applied Math, where we are right now. Linear Algebra, Matrix Multiplication, Dot Products. Alright, you know what? Yeah, screw it. It's impossible to pronounce that. I'm gonna go to something like English to Japanese, and then I'm gonna get this here. This is a translator. I want to go ahead and translate this and hear it. Make sure you guys can hear it too.
Eigenvectors.
Eigenvectors. There we go. Okay, that should do the trick. So, linear algebra, matrix multiplication, dot notations, and eigenvectors. Calculus, gradients, partial derivatives, chain rule, probability and statistics, Bayes' theorem, distribution, and uncertainty. Category 2, classic machine learning, skit-learn. Regressions, linear logistic, ridge. Classification, decision trees, random forest, SVMS. Clustering, k-means, DBSCAN. Dimensional reduction, PCA. Wow. They live today, custom vectors, they're not that tough. Huh, I see. What does that mean, they're not that tough? You learn it easily? Oh, I see, okay. Alright, category 3, model evaluation. Train/test, splits and cross validation. Confusion matrices, precision, recall F1. ROC curves and AUC, haven't heard about them at all. This feels like gibberish to me, I can't lie. Overfitting, underfitting, regularization. Then project 2, build a predictive model from scratch, evaluate it vigorously. Write it up like you're presenting to a client where you are right now precisely. Category 1, applied math. Subtopics, linear algebra. We just covered vectors versus matrices. which is on the ramp matrix multiplication and dot products. To directly answer your structure question, yes, each category has subtopics. I listed them above, and I'm not going to jump categories until the current one is actually covered, not rushed past. That's the pacing philosophy you set. Full exposure per topic, no skipping ahead, just to say we did a category. Want me to keep going deeper into linear algebra now? Next up, matrix multiplication and the dot product, which is the operation that basically every machine learning model runs on. Or do you want to wait a minute and sit down with the roadmap first? I am ready. To for the linear algebra. Okay, well, step by step, everything will make sense. Oh, I see. Game though. Alright, the wuthering waves in the background, you guys can completely ignore that. That is what I do for my break time. Okay, let's go. Vectors and matrices. Worthy vocabulary. Now we get to the operation that actually does something with them. This is the one single most important mathematical operation in all of machine learning, the dot product. I mean that literally when a neural network makes a prediction, when linear regressions fit a line, when an attention mechanism in a transformer decides what to focus on, underneath all of that, at the core is dot products. Learned this one well, and a huge chunk of how does machine learning actually work stops being magic. I see. Okay, what it is, conceptually first, the dot product takes two vectors of the same length, multiplies them element by element, then adds all those products together into one single number. I see. Let's use your house example. Say you have features 3 to 1500. 3 bedrooms, 2 bathrooms, and 1500 square feet. Weights? 10,000 is how much each feature weighs. 5,000 is how much each weight matters. And $100 per feature, I'm assuming. The dot product is 3 multiplied by 10,000. Oh, they multiply the two of those. 2 multiplied by 5,000. 1500 multiplied by 100. 3 times 10,000 is 30,000. 2 times 5,000 is 10,000. 1500 times 100 is 150,000. All of them added up together is 190,000. That's it. That's a predicted house price. 3 numbers describing a house, 3 numbers describing importance, multiplied and summed into one number, a prediction. This is literally what linear regression does under the hood. You're not going to discover some fancier mechanism later. This basic operation scaled up is the most of what's happening inside a model. Before I show you the NumPy syntax for this, quick gut check because I don't want you nodding along if the arithmetic logic isn't landing yet. Does the dot product mechanism make sense? Multiply matching positions, then adding everything upon one number. Yes, makes sense. Sort of walk through it once. It does make sense right now. However, I will forget it later with no practice or recall. There we go, and then let's just go ahead and send it. Oh, I had a typo there. That's honest and it's actually the right... And it's actually the right word to have, better than false confidence, but let me push back on the framing a little, because no practice equals forgetting isn't quite the trap you think here. You're not going to memorize this by drilling it in isolation today and hoping it sticks. You're going to encounter the dot product again in linear regressions when we hit category 2 again, when we build a neural network, netsys forward pass in phase 3. Again in attention mechanisms in phase 4 that repeated re-encounter across real different contexts is what builds recall. Not flashcards, I see. What actually does need to stick right now is in the arithmetic. It's a calculator or NumPy. A calculator or NumPy will always do that for you. What needs to stick is the one sentence intuition, multiply matching pieces and add them up. Get one number that represents how much things align, how much two things align. That sentence is short enough to actually retain, and it's the thing that'll make Phase 3's Transformer math feel familiar instead of brand new. Now, here's the syntax. In NumPy, this whole operation is one function. Let's cement it with code since you learn better when seeing it, yada yada, blah blah blah. Okay, so we import NumPy as NPM, assuming NP is a universal conviction of the way that people really import NumPy in. And then features equals to numpy.array 3 to 1500. Weights equals to numpy.array 10,000, 5,000, $100 per weight. Prediction equals to numpy.the dot method, where I want to go with feature and weights. They multiply the matrix corresponding each column. So 3 multiplies with 10,000, 2 with 5,000, and then they all add it. If I print prediction, it should predict 190,000. Your task, write that in a file, run it yourself, confirm it matches the math, then predict this one before running it. What happens if feature has 3 numbers but weight only has 2 numbers? Don't guess randomly, reason it out. Okay, so first things first, I'm gonna write this stuff. We already got a house, so I'm not gonna go with the... Nah, I won't need any of these. Okay, so we're gonna go with something like house. That is gonna be something like my numpy.theArray method, where my houses array is gonna be 3, 2, 1500. Oh my gosh, are you kidding me? There we go. And then I'm gonna create something like weights. That is gonna be equal to my numpy.array again, where I'm gonna have an array of, let's say, was this 10,000? I think this was 10,000, right? And then the second one was 2 times, no, this was 1500. No, that's 1500, so 2 times 5,000. Nope, let me just fact check that. 5,100, oh god. Okay, that's not something that I need to memorize, so that's fine. 5,000, and that is 100. And then I'm gonna go with something like a prediction variable. Is that how we spell prediction? P-R-E-D-I-C-T-I-O-N. P-R-E-O-D-I-C-T-I-O-N. Prediction is going to be equal to my numpy.the dot method. My dot method is going to be having my house as a parameter and weights as a parameter. Okay, and then I'm just going to go ahead and print my prediction. Okay, let's hit Control S to save the code, and then I'm going to copy my p/numpy.py, and we're going to go ahead and paste it here. Perfect, works. Okay, let me paste that here and say the output was 190,000. My prediction, PREDICTION. Okay, my prediction. So, what was the prediction question? What happens if features has 3 numbers? Whoops. FEATURES. My prediction if feature... Are you kidding me? Hold on. I'm gonna go back here. So we got feature and weights. Features. I'm gonna copy this. This is gonna be features multiplied by weights. Control A, Control C. Copy that. Grab this. Then I'm gonna paste this here. So we got features, we got weights. My prediction if features Okay, if features has only 2 prediction, if weight only had 2 elements in it, is that it would do the regular math. Okay, the regular math, which is 3 multiplied by 10,000. And then let's go with something like 2 multiplied by 5,000. Okay, 5,000. And then add 30, 100,000. What are the weights represent over here? I think it's just a variable for right now. I don't really know what does it mean because we're just working on the math right now. I think that let's give it as a furniture as an example. We've got 3 features in our furnitures. Those 3 features weighs, let's say, 10,000 pounds. I don't know, or like if we give a house example, a house's 3 features weighs like 10,000 pounds, and then there are 2 more features, which is I don't know, 10,000 more pounds. Each feature costs $100, but the context is not what we're working with here. We're working with the math part. And at 30,000 plus 10,000 plus 100, right? Okay, and then let's send it. 190,000 confirmed matches the hand math exactly. Good, that part's solid, but hold on. Read your own prediction back. You said if weights only had 2 elements. Wait, hold on. My bad. 1,500. Real output confirmed matches the actual math. Good, that means mental model is landing correctly. Now your prediction, let's actually examine it carefully instead of me just saying yes or no, because there is a subtle but important flaw in the reasoning. You said it would do 3 multiplied by 10,000, 2 multiplied by 5,000, then somehow tack on 1,500 on multiplied and added. Think about that for a second. What would 1,500 even be multiplied by? Is there no third weight? Only has 2 elements in that scenario. There is nothing at the third position to pair 1,500 with. The dot product score rule is matching positions. Even element 1 of vector A pairs with element 1 of vector B, element 2 with element 2, and so on. If weights run out of elements before features does, there is no partner for that left over 1,500. It's not that NumPy skips the multiplication and just adds the raw number. That would be silently making up a rule that does not exist. So don't guess further, test it, run it. Alright, let's run it and see what happens. I won't get an error, will I? I'm gonna hit Control S to save the code. We're gonna copy py.numpy, and then I'm gonna go ahead and paste it. Value error. Oh, wow. It says not aligned. Oh, okay. We need to learn first linear algebra. Yeah, I think learning linear algebra is the basic. So Claude asked me if I did have any experience with linear algebra. I said I had enough experience with only linear algebra, not with calculus, statistics, probability, and all that stuff. Just linear algebra. Okay, let's sum that here. Also, even though I do have experience with linear algebra, it's not nearly as good. Okay, that's the real answer, and it's a good one to have hit yourself. It doesn't silently guess, it doesn't drop the leftover, it does not do partial math. It flat out refuses and throws a value error. NumPy is telling you in plain English. I don't know how to pair up a third element with nothing to fix your shape before I compute anything. This is actually a critical important lesson that goes way beyond this one exercise. Shape mismatches are one of the most common real-world errors that you will hit in machine learning code constantly. For the rest of the series, every time you feed data into a model, every layer of neural network, every matrix operation, In phase 3 and beyond, shapes have to align or the whole thing throws exactly this kind of error. You just met your first one on purpose in a controlled setting instead of panicking about it 3 months from now during a real project. That's a win, not a detour. I see. Notice the error message itself too. Shapes 3 and 2 not aligned. That 3 and 2 are literally NumPy telling you the size of each array. Learning to read that error format now means you won't be confused about it later. Okay, let's check. Doesn't make sense why mismatch length vectors throws an error instead of computing something. Yes, clear. I think that was as clear as it gets, right? Was it not? Okay, good. That dot product locked in. Same length, vector only. Multiply, matching position, sum into one number. Mismatch shapes throws a value error rather than guessing. Next piece, matrix multiplication. This is the natural next step. Matrix multiplication. Natural next step, up from the dot product. Instead of comparing one vector to one vector, you're comparing a whole stack of vectors, a matrix, against another matrix all at once. This is exactly how a model makes predictions for multiplication houses in one shot instead of running the dot product one house at a time in a loop. Here's the concept before any code. If you have 3 houses, a matrix, 3 rows by 3 columns, and you multiply it by your weights vector, what you're doing is running the dot product once per row and stacking the results. Yeah. 10,000, 5,000, 1,000, 100, I mean. Row 1. Row 1 dot weights. 190,000, you already computed this. Row 2 weights is gonna be 433, okay. This is gonna be 275,000. Row 3 dot weights, it's gonna be 115,000 because it is relatively lower. Result equals to 190,000, 275,000, and 115,000. 3 predictions, 1 per house computed in 1 matrix operation instead of 3 separate loop iterations. Before I show you the NumPy syntax, I want you to compute row 2 and row 3 by hand first. Pick one. Just to confirm the pattern actually clicked and you're not just pattern matching my numbers. Which one do you want to hand verify what you get? Do you mean not do. Did you mean that I need to use a pen and a paper to manually do the math question mark? If that is the case, the math does look correct because it is simple multiplication and addition. Okay, unless Claude meant something else. Oh, and alright, hands off anything else are distracting. Hands off anything that is not distracting. I wasted a whole minute, no. Guys, this is gonna sting me when I'm making my video. That said, moving on. New function unlocked. Expedition motorbike, a lightweight all-terrain vehicle. Code developed by the Department of Exostrider Engineering and the Department of Void Matters at StarTorch Academy. Indispensable for field expedition, the Academy has created specialized driving courses and multiple training tracks around the campus to cater the adventurous spirit of the student and faculty. I see. New function unlocked. Expedition motorbike, a glacier track. An expedition motorbike modified by Luke Person, equipped with the new glacier track module. With this module, the motorbike can freeze water surfaces and travel across them. Another function unlocked. Expedition motorbike aerial tactics module. Equipped with an aerial suspension field, it allows the rider to glide across more complex terrain. Oh wow. Hey, you can view Expedition motorbike features in the terminal. Alright, I'm gonna get this in the side. Okay, the momentum. Search for Yang Yang's frequency. Alright, so I guess we're searching for Yang Yang's frequency. Shape, it's very important to know. I have questions for you. If we multiply matrix with shape 3 by 2, any matrix with shape 2p, what is the shape of the new matrix? I'll actually answer that after my break is over. Okay, because the things that I'm going to be doing here is going to go to my gaming channel. Search Yang Yang's frequency. Oh, I see. A project of Yang Yang? A projection, I mean, my bad. Looks like she's fighting something. Hey, let's just get a quick little screenshot. By screenshot, I meant a quick little snapshot of this stuff. There we go. All I needed. Okay, and then this is another frequency. Wait, she's fighting something. Main quest progress will be displayed on the timeline. So, 3 days ago dawn, 3 mornings ago morning. Click timestamps to view what happened at certain points. Click the resonator avatar to view the resonators' details. Okay, so Chixia and Yang Yang before the gate of Huangfang. Hold on, I'm gonna get this timer a bit higher. To uncover the truth behind the missing person cases, okay. Missing person cases in Jinzhou have been mounting following the clues left by the streams Yang Yang and Chixia prepare to venture into the land of Huangfang to investigate. Alright, what to do next? Hello?
Father, mother, sister, Rover, I don't expect any of you to read these words. If anything, I'd rather say them to your face.
Yeah, time's up, time's up. Alright, hands off anything that's distracting. I'm so glad I could have exited that place. There's no shot I would have exited that stuff without me actually freaking moving it off. I mean, getting the settings off. I didn't want to lose my progress. Okay, this time I'm gonna pay more attention as well when the timer ends, and I'm not gonna spend a whole freaking minute not doing anything. Fair question. Oh wait, by the way, that question. Shape is, it's very important to know. I have questions for you. If you multiply matrix shape 3, 2, any matrix with shape 2p, what is the shape of the new matrix? I think it's 6, 2p, 6, 2p. Does that make sense? Fair question. No pen and paper is required. An honest light should have been clearer. Hand verify means work the arithmetic out yourself mentally on a scratch pad. In your head, whatever, as opposed to what glancing at my numbers and going, yeah, looks right. The point is in writing. Utensil, it's making sure you produce the number, not me. I'll push on this a little because the math looks correct. Isn't quite the same as I computed it. Let's make it concrete. Actually work out row 3 right now and tell me the final number. Okay, so 2, 1, 900 and 10,000, 5,000, 1,000. Oh god. That is going to 2 times 10,000 is going to be 20,000. 1 times 5,000 is going to be 5,000. 900 times 100 is going to be 9,000. Right? Close, but there's an error. Okay, I'm not good at math, okay? What is 9 times 100? Is it 90,000? There it is, 90,000 with 2 zeros added, not 1. That's the actual careful correction, not just accepting a close enough answer. So the full row 3 dot product, 2,000 plus 5,000 plus 9,000 equals to 115,000. Matches exactly what I had. That's real hand verification now, not a glance, and not... Hold Hold on, let me just check if my OBS's audio is going good. My rib bones are killing me for some reason. Okay, and I'm gonna just check my stream real quick. Hold on, I should have done this in my break, but I was playing Valorant then. I just want to check if my voice does not sound robotic. Hold on, let me just check if my... Okay, that's not good. And let me know if the clarity is actually better than before. Because I did like a lot of work to make sure that it's going to be really clear, my stream. Now, the NumPy syntax for doing all three rows at once. This is matrix times vector, and it uses the same dot the same np dot function. It's a method. You already know, just with two dimensional input this time. So houses equals to np.array, exact same thing, just with three different values. Weight is going to be my regular weights. np.dot to house weights, and then prediction is the same thing. I'm gonna just copy the values because I'm not gonna actually type that stuff out. Or will I now? Houses is gonna be equal to my numpy dot array, which is going to be consisting of three values as opposed to just one value this time. Everything else is going to be the same. This is just going to be house. And this is going to be like 100. And then I'm going to hit Control S to save the code, and let's run my program. I'm going to copy my py numpy.py, and then we're going to paste it here. I ran into an error. Type error. Array takes one of two positional arguments, but three arguments were given. Oh yeah, my bad. Because this is supposed to be a list. There we go. Let's hit Control S to save the code. Paste this here again. Oh, okay. Alright. This is houses. Same silly mistakes. There we go. Okay, this wasn't as hard. I'm gonna paste it and then say, done. Yeah, my back's grilling me right now. Okay, real output confirmed. 19, 109,000, 275,000, 115,000. Matches all three hand computer rows exactly. That matrix times vector locked in. Notice you skipped the prediction part though. I asked you to reason out what happens with a fourth element of weight against three column houses before testing it. Not a big deal, just flagging it since precautions are how I check your reasoning from the rule, not just running code and it's reading output. So, quick one before we move on. No need to run it, just reason it from what you already know, okay? What the hell? If houses has 3 columns per row, and weights has 4 columns instead of 3, what happens? Use the same logic as you used with the vector mismatch. We will run into a value error. Correct and correctly reasoned, not guessed. Oh god, it's so freaking scuffed up in here. What the hell? Hold on, let me get a bit back. Can't leave my legs back. And can this get a bit of... Nope, the chair does not get any more. Okay, because I added a big ass HDMI wire so I can connect it to another monitor just specifically for my webcam. Okay, correctly and correctly reasoned, not guess, same rule as before. Matrix time vector still needs the linear dimensions to match. Each row of house has 3 elements, so weights must also have 3 or there's no partner. For the leftover numbers, 4 is not equal to 3. Okay, 4 is not equal to 3. NumPy refuses and throws a value error. Exactly like earlier case, you applied the rule to a new shape instead of needing me to reteach it. That's the whole point of exposure over drilling. Okay, I'll take your word on reasoning here. You don't need to run this one since it's identical, since it's the identical error you already produced and read for real and a few changes ago, not pointing. Burning a tool called to watch the same traceback twice. Okay, I'm gonna drink some water. What the hell? What was that reading, guys? Damn, thirsty out here. Linear algebra checkpoint. Where we stand. Vectors versus matrices done. We know what they mean now. A single row of features versus a stack of them. Dot product matching positions multiply sum to one number. Shape mismatch errors. Why they happen, what the message error tells you. Matrix times vector, running the dot product row by row. In one operation example, how a model predicts on many examples at once. Still ahead in linear algebra. Before we move on to calculus, Ngvectors. I literally got the pronunciation for this. I like literally got it. I meant to go to English to Japanese. My bad. I literally had the... Are you kidding me? Oh my gosh. I had it in the other tab here.
Eigenvectors.
Eigenvectors. Before we move on to calculus, eigenvectors, the last roadmap item under the subtopic. Fair warning, this one's more abstract than we've covered, so no covered so far. No clean house price analogy waiting for it. Want to push into eigenvector or take a breather first? We've been stacking concepts for a while. There we go. Let's go with something like I am using Pomodoro. Okay, therefore I already took my break. Okay, and then I'm just gonna go ahead and send it and make sure this thing is out here. I'm gonna go ahead and exit that, close that stuff. Good, that's the discipline talking, not just checking a box. You pasted, you took the break on your own schedule, came back ready instead, yada yada. Now, moving on, eigenvectors, fair warning again. This is the most abstract thing in linear algebra and there is no house-price analogy that makes it click instantly. Like dot product did, so we're going to build it slow from a question, not a definition. Here's the setup. A matrix isn't a grid of numbers. A matrix isn't just a grid of numbers. A matrix can also be thought of as a transformation. It takes a vector and moves it somewhere, stretches it, squishes it, rotates it, flips it. Where you multiply a matrix by a vector, you're not just doing arithmetic, you're literally transforming that vector into a new one. Most vectors, when transformed this way, change direction. They get rotated or skewed somewhere else on the graph. But for any given matrix, there are small numbers of specific vectors that don't change. Direction, when transformed, they also get stretched or squished, scaled, but they keep pointing the exact same way. Those special direction preserving vectors are called eigenvectors. The amount they get stretched or squished by is called
eigenvectors.
Eigenvalues. There we go. That's the whole concept in one sentence. An eigenvector is a vector that a matrix only scales, it never rotates. Before I go further into why this matters for machine learning, there's a real concrete reason. It's not abstract math for its own sake. It does that does that direction stays the same? Only length changes? Framing makes any sense so far, or is it too abstract with zero visuals yet? Okay, hold on. Here's the setup. A matrix doesn't just take rid of numbers. A matrix can also be thought of as a transformation. It takes a vector and moves it somewhere, stretches it, squishes it, rotates it, and flips it. When you multiply a matrix by a vector, you're not just doing arithmetic, you're literally transforming that vector into a new one. Most vectors, when transformed this way, change direction. They get rotated or skewed somewhere else on the graph, okay? But for any given matrix, there's a small number of specific vectors that don't change direction when they don't change direction when transformed. They only get stretched and squished, scaled, but they keep pointing the exact same way. Those special direction preserving vectors are called eigenvectors. The amount they get stretched or squished is called eigenvalues. Before I go any further into why this matters for machine learning, there's a real concrete reason. It's not abstract math for its own sake. Does that direction stay in the same, only length changes? Farming makes sense so far. Framing makes sense so far. Is it too abstract? I mean, I did not understand. However, I feel like I did understand. It is a vague way to describe it. Okay, and then I'm gonna go ahead and send it. Good catch on yourself. I feel like I understood, but it's vague. It's actually the most honest and useful place to be right now because it tells me the words made sense, but there is no real picture behind them yet. That's exactly the gap I need to close, not paper over. You said it needs a real-world angle to land. Let's use one instead of more abstract language. Imagine spinning a basketball on your fingers. Almost every point on that ball is moving in a circle as it spins, changing direction constantly, but there's one line that is not moving in the circle at all. The spin axis, the imagery line running straight through the ball from the point resisting on your finger up through the top. Every point on that axis line just stays exactly where it is in the exact same direction while everything else around it, while everything swings around it. Every point on that axis just stays exactly where it is, the direction, okay? That axis line is basically an eigenvector of the spinning transformation. Everything else in the transformation gets rotated somewhere new. The axis is the one direction that transformation leaves alone. It doesn't get pushed off. Its line, it just is the line the whole thing rotates around. I see. Now tie that back to a matrix. A matrix transformation grabs a vector and can rotate it, stretch it, flip it, moves it somewhere new on the graph, same as spinning moves the most points on that ball. But for that specific matrix, there exists a small number of special vectors. Like that spin axis, that matrix does not rotate. It might stretch that vector longer or shrink it shorter, but it stays pointing the same direction. That's the eigenvector. How much it stretches or shrinks is the eigenvalue. I understand, but I do not understand it well enough to explain it. Okay, and then let's send it. I had a typo and understand. Good distinction to draw. And honestly, that's a completely fair place to be after one explanation of the single most abstract concept in this whole subtopic. I get it when I hear it, I can produce it from scratch is a real normal stage. It's not a red flag, it's not the finish line yet. Here's the one thing though. Remember what I told you back on the dot product? This isn't going to stick for me re-explaining it 5 more times. 5 more different ways today. It sticks from repeated re-encounter across different contexts. That does make sense. And eigenvectors specifically show up later again in this exact phase in PCA, dimensional reduction, where you'll see them doing actual work on real data instead of just hearing about a spinning ball. That's when the abstract idea turns into something you can explain because you'll have watched it do something useful. Okay, if something showed you 3 vectors and asked which one is an eigenvector of some matrix, what would you be looking for? A vector that changes direction under the transformation, a vector that keeps direction, only gets scaled, a vector that becomes 0 after the transformation. Whoops, hold on. A vector that changes direction, no, a vector that keeps its direction. That's the correct recognition, and that's actually the bar I set for today. You correctly picked out keeps direction, only gets scaled over the distractions, which means the core idea did land, even if you can't freehand hyphen explain it from scratch yet. The gap will close later in PCA when you see it working on real data, not something you force today. New to stream, what are you learning today? Actually, I am currently, if you're like new to the stream, I could explain the entire thing. Hold on, let me grab my roadmap. So basically, I did start a new programming for our AI engineering for 365 days. A roadmap where my goal by the end of the series will be to make a fully autonomous agentic AI, where my roadmap consists of 8 phases in total, starting from the bedrock phase all the way till my capstone phase. At the end of every phase, I have a mini project that I built. For example, the mini project that I was done building yesterday was a fully automated web scraper. And in order to build this project, under phase 1, I've got a bunch of categories and subcategories, each acting as its own prerequisites for the upcoming phases. Currently, I'm under my phase 2, which is math and machine learning. I just started it today, therefore I'm in the linear algebras category, which got a bunch of subcategories, or more specifically 3 subcategories. It's got math matrix multiplication, which I'm done with, dot products that I was done with as well, and eigenvectors, which I am currently working on. Later on, I will be working on calculus and probability, and that's pretty much it for right now. I am following a Pomodoro as well, which is every 25 minutes I get a 5 minutes break, and after 4 sessions of 25 minutes, I get a 15 minutes break. That said, I play Wuthering Waves. It gives me free content for my gaming channel as well. And if you guys do not really know how to get access to my gaming channel, it's not really that hard. If you guys do go to my homepage, scroll all the way down, I have both my channels linked here. You guys can check it out. That said, okay, linear algebra fully covered. Wait, actually, I'm done with linear algebra. What the hell? Eigenvectors, recognition level, direction preserved, only scaled. Alright, I guess we're done with vectors. Where's the matrices, dot product, math matrix. Matrix times vector, shape mismatch errors, okay, and eigenvectors, we're done with that all. That's the whole linear algebra subtopic done per the roadmap. Multiplication matrix, dot product, eigenvectors, all touched, none skipped. Next up in the applied math is calculus, gradients, partial derivatives, chain rule. This one's actually going to connect back to what you just did, because a gradient is basically which direction do I nudge my weights to make my prediction less wrong. And you already know what weights and predictions are from. The dot product work. I see. Yeah, I do know it. Okay, that said, given your Pomodoro cycle, want to push into calculus now, or is it a good time for stopping? We can keep pushing. And yeah, I am touch typing as well. That's it. I'm going to drink some water. By God, I'm so thirsty. Alright, so good. Momentum's still there. So let's use it. This next one connects directly to what you just built. So it should feel less starting over and more like the next chapter of some of the same story. Calculus, machine learning style, starting with the derivative. Hold on a damn minute.
Derivative.
Okay, so starting with the derivative. Forget the textbook definition for a second. There was no textbook definition. Here's the machine learning framing. A derivative tells you how much a small change in one thing causes a change in another thing. A derivative tells you how much a small change in one thing causes a change in another thing. Tied back to your house example, remember the prediction formula? Prediction equal to bedrooms multiplied by weight 1, bathrooms multiplied by weight 2, square feet multiplied by weight 3. Right now, those weight 1, weight 2, and weight 3 are numbers I just made up, 10,000, 5,000, 100. In reality, a model does not know the right weight up front. It has to learn them by trial and error, starting with random weights, checking how wrong the prediction is, then nudging each weight slightly to make the prediction less wrong. Repeat thousands of times. The derivative is what tells the model which direction to nudge each weight. If increasing weight 3, the square feet weight, makes the prediction error go down, the derivative for weight 3 will point that direction. Increase me. If increasing makes the error go up, the derivative points the other way. Decrease me. Oh, I see. That's the entire intuition. A derivative in a direction and size signal for how should I change this number to get a better result. Oh, okay. Does derivative. All right, guys. Hands off anything that's not distracting. It's time for a break. Hands off anything that is not distractive or it's productive. Moving on. Fighting them. And this is Yang Yang, right? Escape the auto puppets encirclement. I think we're getting like Yang Yang's POV. She's escaping. Oh. Oh wow, we're fighting a freaking beast here. This is what I... Shape the shapeless? Is that what it said? I would suggest solving functions that contains exponential. Hold on, I'll read that in a bit. Oh, I'm running away. Am I gonna jump off the cliff? Hold on a cliff minute. I mean, hold on a damn minute.
Be far enough now.
Is Rover gonna come and save her? That's the most cliche stuff that I've said, but...
This way. Shizuo will be safe.
Getting goosebumps, what the hell? Wait, is she gonna be alright? What's up? Everything's going fuzzy.
Liang Yu, these auto puppets, they seem...
They see him.
Watch out!
What is this? Why are the auto puppets...
What accent is it?
Go. I will hold the rear.
Paragon Xingqiao, you...
I will go back for the others. Do not worry.
But...
Is this her
Anyone
life
still
flashing?
standing? With me! Push through!
Is it her life flashing before her eyes?
We have to get word back. To Xuanfeng hold.
These voices. What are...
Oh god! Oh my gosh, the...
A rafter kite.
Ah.
Why did it fly here? Ah, that's...
Damn!
Watch it, Liang Yu! Someone's fighting the auto puppets over there.
At a time like this, how is that? Everyone, get in formation. Keep them away from the village. Hey, are you all right?
I...
Alright, everything's just gone... Ooh.
But in all these years, nothing like this has ever happened. Many still refuse to leave their homes.
Alright, I'm gonna call it. I'm gonna call it there. Hands off anything that is distracting now. I'm gonna continue that after my timer is up. There we go. Back to work, y'all. I would suggest solving functions that contains exponents for partial derivatives or calculus 3. Specifically, it's really helpful for deep learning practice questions mathematically, at least when you get to calculus. I see. I'm probably gonna try it in that case. Okay, does derivity equal signal for which direction to nudge a number to improve the results? Make sense so far? Sort of, I want a different angle. Okay, fair, sort of, is exactly why I asked instead of barreling forward, let's ground it with something more physical than weights and predictions. Since that's a fairly abstract setup, think about a hiking trail on a hill. In the fog, you can see the whole hill, you can only feel the ground ride. Where you're standing, you want to go to the bottom of the hill, the lowest point, all you can feel is the ground. Slopping up under my left foot or slopping down. That slope you feel under your feet, right where you're standing right now. What's the derivative? That slope you feel under your feet. Okay, it's not the whole hill's shape, it's just at this exact point, which way is down. If the ground slopes down to your left, the derivative tells you step left. If it slopes down to your right, it tells you step right. You take a small step in that direction, then check the slope again for your new spot and repeat, slowly working your way down to the bottom of the hill, one small step at a time, purely by feeling the local slope each time. Now, map that back to machine learning. The hill is the model's error. The wrong is the how wrong its predictions are. Okay. The hill is the model's error. The bottom of the hill is the lowest possible error. The best model can do. Okay. The weight, like your square feet, W3, is your position on the hill. The derivative is the slope you feel under your feet at your current weight value. Telling you increase this weight or decrease this weight. To move towards lower error, this step-by-step walk downhill has an actual name in machine learning: gradient descent. You'll hear that term constantly starting in phase 3. Does that fog and hillside version make that which direction to nudge idea land better? It did not, because I am bad with geology and slopes. Wait, isn't geology the study of rocks? I think it's geography. There we go. Good to know geography metaphors aren't on your ramp. That's useful information, not a failure. Pure number versions, no hill, no fog. Say your model currently predicts a house costs $150,000, but real price is $200,000. Your model is wrong by $50,000 too low. You have one weight. You're allowed to adjust the square feet weight, currently 100. The question the derivative answers is dead simple. If I bump this weight up a little, does my prediction get closer to 200,000 or further away? Oh, let's actually test it with real numbers, no metaphor. Current square feet is 1500. Weight multiplied by 100 equals to 150,000. Too low, needs to go up. Try increasing the weight to 110. 150 multiplied by 110 equals 165,000. Closer to 200,000, better. Try decreasing weight to 90, 150, 135, further from 200. That's it. Oh, I see. That's the whole derivative. In the specific case, testing does nudging in this number help or hurt, seeing that upheld. So the derivative points increase the weights, no slopes, no hills. Just try a small change, see if the error shrinks or grows, and that tells you which direction to keep going. Oh, I see. So it keeps on doing trial and error in order to get / give the best possible result. Right? There we go. How old are you? Alright guys, I see. No need to spam. I'm gonna go ahead and let's say delete. I am 18 years though. I'm gonna be turning 19 this January 5th. Okay, and then I'm just gonna go ahead and remove that. There we go. One question should be good, because I do see the comments instantly. I just reply to them once I'm done reading my stuff here. Yes, that's it. That's exactly it. That's not just close enough. That's the actual mechanism said in your own words, and it's correct. That's genuinely most of what training a model is. Repeated trial and error, nudging of numbers until the error shrinks as much as possible. You just described gradient descent in plain English without me feeding you the term first. Gradient descent. One precision add, not a correction, just sharpening it. A real machine learning does not do blind trial and error randomly, guessing up or down and checking. The derivative actually calculates the direction mathematically in one step using a formula. It does not need to test. Try 110, try 90, like we just did by hand. What we did manually just now was a slowed down visible version of what the derivative computes instantly. Same idea, just automated and exact instead of a guess and check. Now, the roadmap has two more calculus terms tied to the exact same idea: gradient and partial derivative. Good news, you basically already know both. They're just extensions of what you just nailed. Partial derivative, you have multiple weights: bedroom weight, bathroom weight, square feet weight. Not just one. A partial derivative is how much does the error change if I nudge. Just this one weight, just this one weight, holding all the others still. You do that separately, one weight at a time. Gradient, once you've done that for every weight, you bundle all those individual nudge directions into one vector. That vector, remember what a vector is the gradient. Okay, vector is a all the elements in a list or in an array. That's a vector. Okay, matrix is multiple vectors stacked inside of a list. Okay, a vector is the gradient. It's literally just here's the nudge direction for weight 1 and weight 2 and weight 3 all packed into one list. Sounds familiar? Same relationship as dot product on one vector versus matrix multiplication on many, one at a time versus all at once, bundled into a vector. Does gradient equals to a vector holding the nudge direction for every weight at once? Like, given what you just figured out, it makes sense. However, it is only in my working memory and not my long term. How? I mean, I do understand it for the time being, though. There we go, and then let's just go ahead and send it. And that's an honest and accurate thing to flag, and I want to be straight with you about it rather than just reassuring you that's expected and it's fine. You're not supposed to have gradient descent locked into long-term memory after 120 minutes pass through it with a hand-computed example. Nobody does. That's not how this works, and that's not how it works. Not a gap in you. Here's the actual mechanism that moves something from working memory to long-term memory, and it's the idea. It's the same thing I told you back on the dot product. We encounter across different real contexts. Not repetition of the same explanation, you're going to run into gradient and derivative again later in this phase when linear regression is skit-learn actually trains a model using this exact process. Alright. Okay, in phase 3, when you write a PyTorch training loop and call it backward, okay, blah blah blah, each time you see it again, it takes less re-explanation because the shape of the idea is already sitting in your head, even if the fine details faded. That's the exposure first pacing philosophy working as intended. You're not supposed to grind this into permanence today. Calculus checkpoint covered at exposure level. Derivative, small nudge, does either shrink or grow. That's your direction. Partial derivative, same idea, but for one weight at a time when there are several. Gradient, bundle all those individual nudges directly into one vector. How's your focus right now? Keep going into chain rule. I think I can keep going into chain rule. I'm not as exhausted. The thing is, my freaking back is killing me. What the hell? Okay, good. Trust that self-check since you've been accurate about your own state all session. Let's go. Chain rule. Here's why this one exists and why it matters for you specifically. Your house price model only had one step. Features times weight. Features times weights. Done. But a real neural network has many layers stacked on top of each other. The output of layer 1 feeds into layer 2, which feeds into layer 3, and so on. The chain rule is what lets you figure out how does a nudge to a weight all the way back in layer 1 affect final error several layers later. Real world angle, since geography didn't land for you, let's use something mechanical instead. Picture a line of dominoes, or better, gears. Gear A turns gear B turns gear C turns gear D. If you want to know how much does gear D move if I nudge gear A at a tiny bit, you can skip straight from A to D. You have to trace the effect through each connection, how much A affects B, times how much B affects C, times how much C affects D, multiply the effects along the chain, link by link, and you get the total effect from start to finish. That's the chain rule in full. When one thing affects another, which affects another, which affects another, you find the total effect by multiplying each individual link's effect together. What did I just read? Was that supposed to be like a tongue twister? Hold on, I need to hydrate my lips real quick. Okay, I'm gonna, even though I have a chapstick, I don't know where it is. I want to test my camera's zoom, so I'm gonna be showing you guys the chapstick that I will be using just to test my camera's zoom real quick. I wonder if you guys can see it. Oh god, guys, I'm gonna trip on this freaking HDMI wire. I want to firstly see if you guys can see it from my gameplay screen. Since you guys cannot, I'm gonna go to my just chatting. There we go. Okay, so I am currently using, I'm gonna be using this. I'm just testing my camera's zoom here, because I set it to be auto zoom. How do people do this? There we go. Okay, so we got a lip balm, watermelon. There. I want it to be clear. I need to adjust my hands. There we go. Perfect. I just wanted to see if my camera would actually capture that. Because the last time I added a shot about it, I don't know if I was lazy and I did add or I did not add a shot about it. There we go. It did not show any text. I thought that was just because my camera wasn't as clear to show text. Apparently not. It was. I was just an idiot, not trying to use it not trying to use it as its full potential or on its full potential. Okay, I'm gonna go to my gameplay screen again. Okay, at least I know that it's not the camera that's bad. Okay. Tied to machine learning directly, a weight back in an early layer of network does not directly touch the final error. It affects the next layer, which affects the next layer after that, which eventually affects the final prediction, which determines the error. Chain rule is how you trace that multiple step influence back link by link, so you know how to nudge that early weight correctly. Does the gear chain version of trace the effect through each link multiplied together land? It makes sense for now. Okay, I'm gonna go ahead and send it. For now, good honest answer, and that's the right expectation to hold. Same gradient a minute ago. Chain rule is genuinely the most abstract link in this entire whole chapter. And it gets a real cementing moment in phase 3 when you watch PyTorch's dot backwards actually. Trace gradients backwards through a multi-layer network. That's when gears turn. That's when gears turning other gears turns into something you're watching happen in real code layer by layer. Today was just exposure and you got it. Alright. Calculus fully covered per roadmap. Gradients, a bundle of nudge directions, one per weight. Partial derivatives, nudge. Okay, what does a nudge even mean? What does a nudge mean? Alright, let's get it here. Nudge is poke, elbow, and all that. I don't know if I can go to dictionary on stream. People were nudging each other and pointing at me. Nudge definition. There we go. Someone gently, typically with others' elbow. Oh, alright. Partial derivatives nudge direction. Slightly push the direction for one weight in isolation. Chain rule, trace effect. Okay, that closes out 2 of the applied math subtopics. 1 left, probability and statistics. A Bayes theorem, distribution, uncertainty. This is a good natural pause point too if you want 1 linear algebra. Keep going. Stop here for this session. I want to stop here. However, I have 2 questions. Okay, so for my 2 questions, what does a nudge mean? And can you help me commit my phase 1 folder to my GitHub? And that if something from my phase 1 is already in GitHub, will I have duplicates or will it be replaced? Okay, and then I'm just gonna go ahead and send it. Good stopping point, linear algebra and calculus both fully closed. A clean handoff into probability. Next time, let's handle both questions before we wrap. What does nudge mean plain English? No jargon. A nudge is just a small adjustment to a number, a tiny increase or decrease. When I said nudge the weights, I meant literally take the weight's current value and bump it slightly higher. 100 to 110, that's it. Not a technical machine learning term with the hidden meanings, okay? Committing phase 1 into GitHub. Before I touch this, one thing to flag first per your own stating rule. Your database password is currently sitting as a placeholder in your project 1. And proper environment handling was explicitly deferred, okay? Until closer to when this gets committed, that's... Okay, that time is now. Before we push anything, we need to make sure no real credentials end up in the commit. That's not me being overly cautious, that's my, okay? On duplicate questions specifically, it depends entirely on stuff. Has your engineering folder been connected to the GitHub repository before? Okay, it has. And don't worry. I do not have my real password saved anywhere. Alright, besides that one place. Good to hear. Okay, but let's not just take as settled. Let's actually verify it. Git status. Okay, so apparently I'm gonna go ahead and run git status. Git status sort of reminds me of get status. Okay, no repository yet. I'm gonna go and change my directory to my phase 1. Wait. Not a git repository of the parent directories. Okay. Change directory. So let's go with cd. Phase _1. Okay, and then we're gonna go with git status. Okay, I get this header. And then I'm gonna grab Cloud here real quick, paste it, and say I get this error. Okay, and then let's send it. Good, that error is actually really useful information, not dead end. It tells something important. Your top layer of the entry folder is not itself a Git repository, and neither is the phase 1 subfolder inside it. No .git folder exists in that location. That directly contradicts the earlier answer that this repository already exists and has been pushed before. At least for this folder, a new real possibility, and we shouldn't guess, we should check. Do you have a separate local folder elsewhere in your machine that actually get repository? Let's check. So global list. Okay, so we have this. Then I'm gonna go ahead and copy that, paste it here. Good, that confirms Git is configured in your machine under your identity of the universe. That email, so you've sent it up here before, but that still doesn't tell us whether this specific folder was ever connected to a remote, or is it just confirm your identity given where we're at. This has turned into a real unfinished business repository. Status unclear, password safety needs verifying before we push. Let me generate you the transfer prompt, okay? You know what, in that case, I think that I should just... Hold on. I'm gonna probably send Claude my GitHub real quick. Let me open GitHub. Hold on. Okay, where's GitHub? There we go. And then I'm gonna just log into it. There's no way I don't have it saved. I'm not signed in, are you kidding me? Viv Universal, what email did I have for it? Hold on. There we go. So apparently that is my GitHub in my GitHub. 6 repositories, 1 follower. IDK, huh? Profile. Guys, I need to learn how to use this GitHub here. How do I have 23 followers? I don't even do anything in GitHub. 365 days of AI engineering where I got these bunch of files in here. I could probably just send this picture and I'll be probably good. I have all 2 months ago. We have a readme. Language, okay. You know what? I'm probably gonna go ahead and do this stuff off stream. For the time being, I'm gonna go to my main camera. And yeah, I'm probably just gonna go ahead and play my Wuthering Waves for my final break, and then we're just gonna call it a day. I do want to start 10 seconds sooner, so I'm just gonna wait for the time to run out. Okay, so we have 6, and 5, 4, 3, 2, 1. Hands off anything that is not distracting.
They're emergency orders from the commander. Everyone outside the hold falls back inside.
Okay, I was just making sure if my desktop audio is there. Alright, let's go.
Zhuang Feng has always stood under the Sentinel's protection. How could this possibly?
I'm gonna get my timer down here.
I told you. We cannot reach the Sentinel right now.
Where am I? This place is...
The mechanical bird.
You are...
Alright, so leave the house. Optional, investigate the room. Let's go ahead for investigating. A paragraph from a diary. Still haven't learned that song from last time? Grandpa said he's going to hire a musician from Medzowu City to teach me. But I'm kind of over it. I should tell him soon so he doesn't waste his money. Oh wow, this is long. Grandpa took me Huangfang Hall today. It's huge and impressive, so much good food and fun stuff. On the way back, I saw someone flying into the sky on a good sword. Was that a real transcendent? Does Huang taught me a few moves today. He said I'm a natural. I think so too. Swinging swords and spears is way more fun than playing games, than playing the Lewiquin? Guys, I'm awful at these pronunciations. What the hell? If I can get into the Ministry of War, it'll really make Grandpa proud. The exam results are out. The examiner said my scores are good enough to work at the Mengzu City branch. I've only been there once. It's very different from Huangfang, and I'm not sure how I feel about it. But moving somewhere new could be fun. Grandpa and the elders want me to go, but if I leave, who's gonna take care of him? He does not have any kids of his own. I'm all he has. It's a lot to take in. I need more time to think. When that tacit discord pushed me off the cliff, I thought I was dead for sure. I can't believe I became a resonator. Controlling wind is actually quite handy. Just one thing. Why did my tacit mark have to appear on the back of my neck? I can't even see it. Oh, wow. Okay, now let's get the hell out of this place. I've got a bad feeling. Where did I go? Where do I go? I'm lost. Wait, somewhere there? Oh, there. All right, let's dip. All right. There we go. It's all black.
Excuse me.
Oh, you're awake. You almost overclocked and have been unconscious for hours. How do you feel? Anything hurt?
I'm fine. I just don't understand what's happening.
Name's Liang Yu. I'm a Xuan Watcher under the Ministry of War, stationed at Xuanfang Hold. This is Xianling Village, at the foot of the Eastern Xuan Peaks. Most folks here are locals.
I see.
Xuan Watcher. Xianling Village.
Now, answer my questions. Who are you? Why are you here? And why were you fighting the auto puppets?
I am Yang Yang, Outrider under Jinzhou's Midnight Rangers. I came to Xuanfang to help the patrollers investigate the recent disappearances in Jinzhou. My partner and I followed the trail through the Dreaming Cavern, but we ran into a large swarm of tacit discords outside the mountain gate. But then it suddenly opened. To buy my partner time to escape, I went in alone to draw them off. What came after that, you already know.
Jinzhou. Folks going missing, tacit discords running wild, the gate opening by itself. Jinzhou hasn't been informed. Mengzhou won't answer. What is all this?
I thought the auto puppets of Xuanfang Hold were meant to aid soldiers against tacit discords. Why did they turn on the people?
I don't know. Nobody does.
Liang Yu gives Yang Yang a brief account of events. Liang Yu, is that how you pronounce the name?
The auto puppets rebelled?
No one is willing to believe it. The auto puppets are creations of Mengzhou's Sentinel. Under no rightful circumstance should they ever spill the blood of innocents. And even if someone was pulling their strings, using them to throw Xuanfang into chaos, it's unthinkable. It would mean someone has the means to breach, maybe even unravel the Sentinel's own intelligence.
If this was all orchestrated from the shadows, then the only force I know that might be capable of such a thing is... Could this be the work of the Fraxidus?
The Fraxidus? That infamous terrorist organization? I can't say. At the very least, we have seen no one in red robes within these lands for a very long time. If only George and Atelier could send 1 or 2 Helmsmasters right now. No. Wishful thinking.
George and Atelier. Who are they?
Was that French?
A Mengzhou organization devoted to mechanist art. Nearly half the craftsmen in Mengzhou have ties to George and Atelier. When it comes to mechanisms, they're second only to Sentinel Sheen and the Ministry of Development. But unlike the Ministry of Development or Huashu Academy, they don't answer to City Hall. Their leadership rarely shows itself. Now that Xuanfeng has lost contact with Mengzhou, whatever the truth may be, the safety of the people comes first. As for the missing travelers from Jinzhou, I'm sorry. The Ministry of War never received word of them, and in our current situation, I fear we cannot spare the manpower to assist your investigation.
Please don't apologize. I have no proof. But I can't shake the feeling that all of this is connected somehow. Besides, as comrades in arms, we should stand by one another. If there's any way I can help, you need only say the word.
Thank you. We are short of hands. Many of our soldiers were wounded in the clash with the auto puppets. They need time to recover. Once our scouts have mapped a safe route back to the hold, we'll escort everyone out of here.
Okay, so they're basically all in danger.
Until then, I'll go check on the villagers.
Much appreciated.
The auto puppets could strike again at any moment.
Alright, so I'm gonna go
We
and
need
check
to
on
get
the
everyone to
villagers.
a safe rally point. And I should talk to the wardens to learn more about Xuanfeng.
I'm sorry, just passing by. There we go. Just get a meter away.
You mean? Young.
Oh, I was
Yes.
knocking.
I'm sorry, Auntie. We couldn't bring him home. Please, stay strong.
Oh? The villagers are not doing good. By not being home, did they mean that someone died? Knock knock. Knock knock.
Who is it?
Ooh.
Please hurry. The wardens want everyone gathered in the village square.
All right. I understand. Shall we? Pack your things. We're going to Xuanfeng Hold.
We're going inside the big walls? Then can I go see Uncle Cho?
We will not trouble Uncle Cho. He's very busy.
Alright, so optional talk to the villager. Now I'm gonna go and check my quiz. I mean, I'm gonna go ahead and check on the other villagers. Knock knock. Knock knock.
Looks like this house is already empty. I've checked out most of the village by now.
Talk to
Time to speak with the
Xuanfeng.
warden and see how things stand.
Talk to Xuanfeng warden in the village. Okay, before I go over and talk to the warden, I'm gonna go ahead and claim all the freebies from here. Any of my favorite characters here? Okay, out of them all, this is the only one who I like. But I'm gonna claim all the free stuff. Rewards. Wait, it's saying to go somewhere. I don't want to go with 3 minutes left on the clock. Nope, I'm gonna go later. I'm gonna just claim everything today. We got events, which is all claimed, and then I've got expedition motorbike. Let's go, let's go. Okay. Oh, click here to view modeling tasks and earn modeling points. Complete tasks and earn modeling points. Also, I can remodel my vehicle. Click here to expedition motorbike expansion modules. Select the bounce jump expansion module. Upgrade. Successfully upgraded. Alright. Oh, I'm gonna claim. Give me all the free stuff. I'm gonna hoard the frick out of this. Okay, that said, I'm gonna go ahead and move on to my trophies, which I've been pending to claim for a long time. Let's go ahead and claim it all. Well, that was anticlimactic. Yeah, I'm gonna go to my, let's say, Queen, just to see any new characters that have come. Okay, tomorrow new characters are gonna come. I've been saving my asteroids for like a good character. I would have summoned on, what was her name? Yinlin, but I did not really. I held myself back waiting for any other broken character or the, white, Geed samurai. The samurai that wears like a white gi. I forgot her name. It starts with an H. Akyu or something like that. Or even Zani actually. I like the two of those characters. I'm gonna probably wait for their rerun. That said, I guess we're gonna go ahead and talk to the Wangfang's warden.
Speeding up.
Oh, there.
So you're the one who held off more than a dozen auto puppets on your own. That is no small feat. Liang Yu said you're an outrider from Jinzhou. I should have guessed. The front lines against tacit discords do not breed ordinary soldiers. Only the finest make it there.
I wouldn't go that far. But those tacit discords I fought here, they were nothing like the ones I fought before. They were fast, vicious, like veterans tempered by countless battles.
Okay, I was just making sure that you guys can hear the desktop audio.
For 2 centuries, Shuangfang's central courts have purged TDs within its borders. Anything that survived the auto puppets and generations of wardens would have to be brutal and cunning.
Alright, I'm just gonna open that because I'm gonna close my timer once it's over.
Though to be fair, the auto puppets do the heavy lifting. We wardens mostly support them in combat. Back then, only a few people could face powerful tacit discords alone. The Warden Commander, the Swan Triad Watchers, and that elusive Swan Paragon. But now the auto puppets have turned on us. The Paragon is trapped in a censure court, and of the Triad, only Liang Yu remains. Even if we retreat to the hold, we still will not be able to stop what's coming.
Alright, I'm gonna close my timer and I'm gonna pause it and then I'm gonna restart it. Because I'm pretty much done with today. I'm just gonna complete the storyline and call it a day.
Well,
it's okay. I don't need comforting. After decades in uniform, you learn to make peace with whatever may come. It is only, if you are willing, comrade, do us one favor. Look after Liang Yu. She has talent, but she is still young. Most days, the other 2 watchers kept her under their wing, like an older brother and sister. She saw them the same way. The battlefield has no place for tears, but any eye can see their deaths have left their mark. A leader cannot afford to show weakness before the ranks. Liang Yu is too proud for that. She will only bury it inside. You look to be about her age, and you're not of the Shuangfang Wardens. So, she might open up to you.
understood. I'll do what I can to help lighten her burden. It's clear she means a great deal to all of you.
Of course she does. She lost her parents young and was raised by the whole village. For us, it's hard not to think of her as our little sister.
This game is basically all story.
In any case, I leave it to you.
Let's go, I jinxed it!
It's trying to lead me somewhere. Let's see where it goes.
follow the Raptor Kite. I will be following later on next stream. For the time being, I'm gonna go ahead and let's say move on to my main camera. Alright guys, so basically that was pretty much it for the stream, and let me know how, did this new camera do good or bad for my should I say camera quality, because I am currently, before I used to directly stream through my webcam, now I'm streaming using my Logitech Options' literal app. And I'm just sharing a window to my OBS, and I did crop everything besides my actual webcam, which does prove that the zoom sort of works besides the light compensation. I just got to get rid of the light and show this, for which I need to get in front. But besides all that stuff, that was pretty much it for the stream. If you guys did enjoy the stream, don't forget to smash that like button, subscribe with notifications turned on, and if you guys do enjoy my content /videos /live streams, make sure to share my channel, because like helps my algorithm sharing, makes you smile, and subscribe like a cheer on top. That said, I stopped multi-streaming or also streaming vertically on YouTube because I wanted to check if it really improves my quality, because now I will be in, or just one video is currently being encoded, so I want to see if it uses all its strength or all its should I say what are the resources in order to encode one live stream with the best quality. If not, then I will start streaming back vertically as well. That's it. If you guys do enjoy my content and haven't followed me in any of my socials yet, you guys can get access to all my socials through the link in the description, through my bio, or by typing !socials on chat. All lowercase, no space. If the social does exist, the link is going to pop up within 3 to 4 seconds. If the social does not exist, the link will not pop up. That said, I did create 2 brand new channels, one called Viv Arcade and the other called Viv Workside. Therefore, Viv Arcade is specifically meant for my gaming content, and Viv Workside is specifically meant for my workout content. Therefore, if you guys are interested in either one of those genres or categories, and that you guys want to follow me there, you guys can get access to both those channels through my YouTube's homepage. If you guys scroll all the way down, you guys will be finding a featured channels section where I have featured both those channels. That said, if you guys do want to follow me in my Engineering for 365 Days series, and that you guys want to use the roadmap that I am currently using for this series, you guys can get access to that roadmap through my Discord server. If you guys either go to the Coding Helps chat, Python chat, or the general chat, mention my name there at VivUniverse, asking me for the roadmap. I will be personally DMing the roadmap to you guys after this stream though. You guys can get access to my Discord server through the link in the description, through my bio, or by typing exclamation and the exclamation Discord on chat, all lowercase, no space. A link should pop up in 3 to 4 seconds. That said, I'll catch you guys next live stream or video. Peace. Okay, I guess let's end the stream.